everybody, today we're going to go over simplifying algebraic expressions. So an algebraic expression is a number sentence without a equal sign that contains a variable. We learned that in section 7.1, but now we're going to simplify them into their lowest form. So let's look at an example of one of the bar graphs or bar diagrams that we learned at the beginning of the chapter. So I see that if I have something with a length of y and another piece with a length of y, to find the total length of this entire bar graph here, I can take y plus y. And y plus y is going to be, I have two y's. So I have two y's here. Okay? I'm combining the like term of y with another like term of y to get 2y. Another example I have here is an equilateral triangle. In this equilateral triangle, all sides of the triangle are the same. So in this one, it's P. To find the perimeter of this triangle, all I have to do is add up all sides of the triangle. So I'm going to say P plus P plus P. Okay? One thing to know is I want you to ask yourself, how many P's in each one of these do I have? All right? The coefficient of P is actually 1. There's a silent 1, I guess, you can think of it as like a silent 1 in front of these because here's 1, here's 1, here's 1. So it's really 1P plus 1P plus 1P to get 3 P's. Okay, so whatever P is, doesn't matter, could be 7, could be a million. I have 3 of them, and that's going to be my perimeter. Okay? I have a rectangle. Okay, and let's also find the perimeter of this rectangle. So in this problem, I see that my length is 3P. But because it's a rectangle, I know that I have 2 of them. I know I have 3P plus 4 plus another 3P plus 4. Okay, and that's going to give me my total perimeter. So one way to think about this is think of them all as terms, but you include the operation. So let me show you what that means. Here's the term 3P. I'm going to draw a line. Plus 4, draw a line. Plus 3P, draw a line. Plus 4. Okay? Now I'm going to look for my like terms. When I have 3P, the only thing I can combine with 3P is another term that also has P. So the other term that also has P is 3P. So I'm going to combine 3P plus 3P. 3P plus 3P is 6P. Then I have 4. So I did this one and I did this one. Now I have 4. Since 4 does not have a variable, I can only combine it with something else that does not have a variable. So I'm going to combine 4, or positive 4, plus positive 4. 4 plus 4 is 8. And my simplified expression is 6P plus 8. The reason for this is if P was 2, okay, if P equaled 2, in my original equation of 3P plus 4 plus 3P plus 4, I'm going to set that equal to 6P plus 8. Now I'm going to substitute wherever I see P, I'm going to put 2. So it's going to be 3 times 2 plus 4 plus 3 times 2 plus 4 equals 6 times 2 plus 8. So I'm just going to solve the left side first, then the right. 3 times 2 is 6 plus 4 plus 3 times 2 is 6 plus 4 equals 6 plus 4 is 10. And I know I have another 6 plus 4, so that's going to be 20. 6 times 2 is 12 plus 8, and I know that's going to be 20. This expression here had a lot less steps and a lot less substitution than the expression on the left. So that makes it more simple, or it's simplified. It's in its lowest form. On page 231, I would like you to try the guided practice problems 1, 2, 3, and 4, along with 5 and 6. I would ask you to please pause the video right now so that you can try these answers on your own. On the next slide will be the answers, or try these problems on your own, but I'd like you to try them on your own first, so I'm going to ask you to pause this at this time. Now that you've gone over, now that you tried all the problems, let's go over the answers. In number 1, we see that we have 5 x's. It's really like 1x plus 1x plus 1x plus 1x plus 1x, which gives us 5 x's. It also asked you to identify the coefficient, which is the number before the variable, which would be 5. In number 2, I have a 1y plus a 1y plus 6. I can only combine y's with other y's. So I have 1y plus 1y, which is 2y, and I have 6 as my constant. My coefficient is going to be 2. In number 3, I have 1m plus 1m plus 1m plus 5 plus 4. I can only combine my m's with other m's, so I have 3 m's, and 5 plus 4 is 9. In number 4, I have 6 n's that can be combined together, and 12 minus 8 is 4. So my final answer would be 6n plus 4, and my coefficient is 6. In number 5, it talks about a square having sides of x centimeters. So you know in a square they all have the same lengths. So your total perimeter would be 4x. In number 6, you have a trapezoid with 10 as one side and w is all 3 other sides, which gives us 3w plus 10. Okay, let's go over some more examples on like terms. I'm on page 233 of your textbook. So if I have this diagram, x, 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 okay? It's really like saying I have 3 x's plus another x. So I see here that this is really 4 x's. So 3x plus 1x is going to be 4x. Again, this is how I would split it up to show the terms. I have a positive 3x and a positive 1x. In my second problem of 2v minus v, okay, my whole amount is worth 2v. I know each one's worth v, but I want to know what I have left. When I draw the line in front of each of the operations, I see that I have a positive 2v and a negative 1v. So I have a positive 2v and a negative 1. That's going to leave me with 2 minus 1, which is going to be 1v or v. Okay? Does that make, hopefully that makes sense too. That's why we put the line in front of the operation. I'd like to go back and try one more practice problem before I have you guys try your own, the guided practice on the bottom of the page. So say for instance I have 4z plus 6 minus z minus 4 plus 3z. Okay, so this is a lot longer than the algebraic expressions that we saw previously. So the first thing I want you to do is split these up. So I have 4z line, positive 6 line, negative z line, negative 4 line, positive 3z. Okay? Now I'm going to look for everything that contains a z and all my terms. I have 4z, negative z, and plus 3z. So now this turns into 4z minus 1z plus 3z. So 4z minus 1z is going to be 3z plus another 3z, which is going to be 6z. So now I have 6z as my lowest, my simplest form of z's. Then I have a positive 6 here and a negative 4. Okay, which really turns into 6 minus 4, which will be 2. So since I'm left with a positive 2, my simplest form would be 6z plus 2. Okay, I'd like you to look on the bottom of page 233 and try number 6 through 15. I would ask you to pause the video right now so that you can try, actually I'd like you to do 8 through 20, okay, which is also on page 234. I'd like you to try these in your notebook now, and when you're done we can unpause the video and you can look at the answers. Okay, here are the answers to the on my own problems. Let me go through them just to make sure you know how to do them. So I have x plus 8x, so that's really a 1x plus 8x's equals 9x's. 3r plus 2r equals 5r's. 5y plus 6y is 11y's. In number 10, 3a is going to be equal to 1a plus 1a plus 1a, which is 3a's. In number 11, 2h plus 2h is really 4h, so those are also going to be equivalent. In number 12, I have 2k plus 5, k plus k is really 5, but since I'm multiplying by 5, it's not going to be equivalent to the addition of 5. In 13, I got 6z plus 4z, which is going to equal 10z. But 10 plus 2z is not 10z, so those are not equivalent. In number 14, I have 1p plus 3p, which is going to be 4p. That is not equivalent to 13p. In number 15, 3n plus 2 plus 4n, since I can combine 3n plus 4n to get 7n, and I have a 2, so it's going to be really 2 plus 7n. Those will be equivalent. On page 16, 4s minus s is going to be 3s. 12z minus 7z is going to be 5z. And number 18, 3p minus 3p is going to be 0 because I won't have anything left. And if you put 0p, you know 0 times p is going to be 0 anyway, so 0 is the appropriate answer. In number 19, f minus 6 is not the same as 6 minus f. For example, if f was worth 10, 10 minus 6 is 4, but 6 minus 10 is negative 4, so that will not work. In 20, 5c minus 5c is 0, and a minus a is 0, so those will be equivalent. Okay? Let's go on to one of the last examples or actually there's a couple more examples. No, the last examples that we have here before you start your classwork. So, more than one type of operation, okay? So again, this is very similar, and I think I'm going to make this a little bit more complicated. X plus 6x minus 4 plus y minus 3y. Let's try this one, okay? So again, I'm going to draw the lines in between each one. So I have x plus 6x minus 4 plus y minus 3y. So I'm going to look at the x's first, just because it comes first. That's why I'm going to put that. I know I have 1x plus 6 x's. Those are all the x's I have. So that's going to be 7x. I have a negative 4 here. I don't have any other constants, so that's going to be minus 4. And I have plus y, so this is a plus 1y minus 3y. I want you to think about that. If I'm at 1 on the number line and I'm subtracting 3, I'm going to be at negative 2y. Okay? Now, in general, these should really come in alphabetical order. So my final answer should really be 7x minus 2y minus 4. Okay? In the second one, I have 12 plus y minus 2. Again, split them up. 12 minus 2 is going to be 10 plus y. And in the last one, I have 8x plus 4y minus 6x minus 8y. So I see I have 8x here minus 6x here. I'm going to be left with 2 x's. 4 y's minus 8 y's is going to be a negative 4y. Okay, so whatever your answer is what you write down, and that will give you the operation that you're doing, so plus or minus, okay? I'd like you to pause the video right now and work on the rest of the guided practice problems 1 through 30 in your notebook. I will display the answers once you unpause the video, and then you're going to work on the classwork given to you. If you have any other questions, feel free to email me or to ask, and we'll help you out to the best of our knowledge. Okay, here are the answers to the 21 through 35 guided practice problems. So let's go through them real quick. So I have j plus 3j plus 2j, which is going to equal 6j's. I got 9t minus 3t, which is 6t, minus another 4t, which is going to be 2t's. Oops, I went to 23. I got to go back to 22. 22 is going to be 4j plus 5j plus 2j is 11j's. 5t minus t is 4t, and 4t minus 4t is 0. 25 is going to be 5w. 8w minus 6w is 2w, plus another 3w is 5w. 26 is 7w plus 2w is 9w, and 9w minus 6 is 3w. Number 27, you're looking for a perimeter. I have 6 units plus 2 units, which is going to give me 8 units, and 6x units plus 2x units is going to give me 8x units. So I am left with 8x plus 8. If you put 8 plus 8x, that's okay. 28, I'm going to be left with 7x minus 3. 4x plus 3x is 7x. And then if you'd like to read the rest of these, I got 3y plus 4 for 29, 4y minus 7 for 30, 5z plus 7 for 31, 17z plus 1 for 32, 5g plus 17 for 33, 2g plus 7 for 34, and 35 is 18r plus 18. Okay? So best of luck to you on this lesson. Again, if you have any questions, feel free to ask. Work with one another the best you can. And when I get back, we'll talk about any other questions that you need. Have a great day. Bye.